Let's learn one more topic of quantitative chemistry, that's mole concept, that's concentration of solutions. So in this video we'll learn about what actually means the concentration, that is what is concentrated and dilute solution, what's the definition of concentration, what's the formula of concentration, and at the end we will solve some problems related to concentration, that is some numericals will be solved. Now when we say concentration, what do we mean by the term concentration? That is the biggest question. So let's understand that with the help of some example. Now suppose I have taken a beaker containing some water into it, and then I have dissolved some salt particles into it, that is sodium chloride, common salt I have dissolved into it, and we can see some molecules of NaCl in the water. So you can call this as a salt solution where my water is the solvent and NaCl is a solute. So it's a solution of NaCl, sodium chloride, that is common salt. Now suppose I have taken another beaker with the same solvent as water and NaCl, that is sodium chloride, common salt, as a solute. But now what's the difference between the two beaker? We can see that there are fewer particles of sodium chloride salt dissolved in this second beaker, and there are more number of particles dissolved of sodium chloride in the water. Now that's the reason that we call the second solution a dilute solution and the first solution as concentrated solution. But when we say dilute and concentrated, what does that mean? Dilute means how much dilute and concentrated means how much concentrated is our solution. So that is defined by the term concentration. Now, so what do we mean by the term concentration? Concentration means the amount of solute dissolved in a solvent. So concentration word is used for the solution in which some solute is dissolved in a solvent, and the amount of solvent dissolved can be defined by the term concentration. So when we say that the concentration is the amount of solute dissolved in a solvent, then we need to be more specific to define what amount of solute. So to be more specific, more precise, we can say that the amount of solute in grams or moles that is dissolved in 1 dm cube, that is 1 decimeter cube of a solvent. Now you can call this 1 decimeter cube as 1 liter also. So this is the specific definition of the term concentration. So here is the formula of concentration, which says it's the amount of solute, whether in moles or grams, divided by the volume of the solution in dm cube, decimeter cube. Now with the help of this formula, we can find out any of these three terms which we have defined here. That is, if we know the concentration and volume, we can find out the moles. Or if we know the concentration and moles, we can find out the volume also with this formula. So let's have a triangle of the formula. So when you want to find out concentration, it is moles divided by volume. If you want to find out the volume, then it is moles or grams divided by the concentration. Or if we want to find out the moles, it is concentration multiplied by volume. So with the help of this triangle, you can find out the formula for calculating any of these three terms interrelated with each other. Now let's understand the concept of concentration with the help of some numericals. First example, calculate the concentration in moles per dm cube of sodium hydroxide containing 4 gram of sodium hydroxide in 50 centimeter cube of solution. Now as we have to calculate the concentration in moles per dm cube, our formula for concentration is equal to moles divided by volume in dm cube. But in our question, what is given is the mass of sodium hydroxide and not moles. We are given the volume, but that also in centimeter cube and not in decimeter cube. So the first thing which we need to do is convert the mass into moles and convert the volume into decimeter cube unit. Now, so the formula to calculate the moles is equal to mass upon MR, that is relative molecular mass, and we have learnt this formula in our earlier video, and if you have not seen it, you can go through the first video of the mole concept 01 to find out more about this formula. So let's substitute the values of mass, that is 4 grams, divided by the relative molecular mass of sodium hydroxide, which is 40. So our answer is 0.1 moles. Now about volume. If we have volume in centimeter cube, then we need to divide it by 1000 to change it into decimeter cube, and this gives us the volume of 0.05 decimeter cube. Now let's substitute these values in the formula of concentration. So here is moles, 0.1 divided by 0.05 volume in decimeter cube. So answer is 2 moles per dm cube. Now don't forget to write the unit when we are calculating some amount or some value. So our final answer for the concentration is 2 moles per dm cube. So if we are not given the values of moles and volume directly, we need to calculate it first and then substitute in the formula to get the answer. Now let's take another example. Calculate the mass of potassium hydroxide in 20 centimeter cube of solution of concentration 0.4 moles per dm cube. Now as we are given the value of concentration, that is 0.4 moles per dm cube, so obviously we are supposed to use the formula of concentration, that is concentration is equal to moles divided by volume. But now here we can see that we are given the value of concentration, that is 0.4, and we are given the volume, that is 20 centimeter cube, and that also in centimeter cube. So we are supposed to convert it into decimeter cube first. From this formula we can find out the value of moles, but the calculation says calculate the mass. So let's first calculate the value of moles first, and then we can go ahead to calculate the mass. And so to calculate the moles, we change the formula to concentration multiplied by volume. Our concentration value is 0.4, but what about the volume? Volume is given into centimeter cube, so we need to divide it by 1000, which is 0.02 decimeter cube. Now substitute this into our formula, so multiply by volume, that is 0.02, and so the answer is 0.008 moles of potassium hydroxide. Now we are supposed to calculate the mass of potassium hydroxide for this many volume and concentration. So the formula to calculate the mass is equal to moles into the molecular mass of potassium hydroxide, and substituting the value we have 0.008 into the MR of potassium hydroxide, that is 56. Now if you don't know how to calculate the MR, you can refer the earlier videos of calculating the moles and mass and molecular mass. So here our answer is 0.448 grams. So the mass of potassium hydroxide present in the given volume of a concentration 0.4 is this much, 0.448 grams. Now before we continue with the third example, let's see that in our earlier two examples we had seen how to calculate the concentration. Then in the next example, we had seen that if concentration is given, then we can calculate either moles, or we can even calculate the mass of a given substance, provided that volume is also given. Now in this example, we'll see that we can even calculate the volume of a given solution, provided if concentration and moles are given. So let's read the full question, that is, calculate the volume of hydrochloric acid HCl solution when 0.006 moles of HCl molecules are dissolved to make a solution of concentration 0.24 moles per dm cube. From the triangle of the formula, we can find out that the formula to find out volume is equal to moles divided by the concentration. So the moles given in the question is 0.006. So let's substitute the value, divide by the concentration, which is 0.24, which gives us the answer of 0.025 dm cube. Now obviously the volume calculated is in the unit of decimeter cube, so we can write the answer in dm cube, that is 0.025, or we can write it in centimeter cube also by multiplying it by 1000, which gives us the answer as 25 centimeter cube. So our answer for the volume of HCl of the given concentration and moles is either 0.025 decimeter cube, or it is 25 centimeter cube of the solution. So I hope you understood what does the term concentration means, and then what's the formula for concentration, and then how to use that formula in 3 different ways to calculate the 3 different units of the solution.